Okay, everybody should have these notes out in front of them. Combining like terms, we're going to be using the distributive property. So these two should be two new learning targets for you. Okay, learning target 3 and 4 of Unit 6. So before we begin, go ahead and pause the video. And I want everybody to take a couple minutes. And you need to try to do these problems without the use of your calculator. Okay, do not use your calculator to do so. And then we will go over them. So go ahead and pause the video now. Okay, so let's check. Just to review, there's multiple ways to show multiplication, and you're going to be seeing these different ways when you use the distributive property. So when you multiply two negatives, you will always get a positive answer, as you see in number 1 and number 2 here for multiplication. So those parentheses next to each other with nothing separating them means multiplication. And then the second one, there's one parenthesis, but then there's that multiplication sign right here. Okay, since that multiplication sign is there, it means to multiply. So in number 1, there was no multiplication sign, but there was nothing separating these parentheses here. No operator sign, so that implies multiplication. So in 1, 2, 3, 4, and 5 with the addition and subtraction, you get the same answer for all of these. They're just shown in different ways, so we need to get used to seeing them change the order. Okay, but they still mean the same thing. You'll still get the same answer. And that's because of that commutative property of multiplication. You can switch that order around as long as the signs stay the same. So in number 1, we've got a -3. Okay, and number 2, we still have -3. Number 3, number 4, and number 5, it's always a -3 no matter where it's at in the problem. Okay, so to point that out, if I get rid of that 2 right there, I still have -3. Okay, if we get rid of this, we still have -3 and so on. Okay, we're going to review some terms that I know we've talked about before. Okay, variable and constant. So x here is our variable. Our constant here could be 5, and it's also 7, just a number all by itself. And the coefficient, remember that coefficient is this number in front that's being multiplied by a variable. And a term is separated by an operator. So here we would have one term, two terms, and a third term. Okay, and right now in this problem up here, we have an exponent of 1 for the x, where in this example down here, we have an exponent of 2. So if there's any questions on this page, we want to make sure we stop and ask. And if not, we're going to move on. But these definitions are really important for understanding the lesson and moving forward with the unit. So we know about terms, but now we need to talk about like terms. So like terms must have the exact same variable raised to the same exponent. So in the first example, let's first just identify how many terms there are. So I'll do the first one for us. So we've got 3 terms. I've got one term here, another term here, and another term right here. So we've got 3 terms total, and now we need to identify what those like terms are. So like term, same variable raised to that same exponent. So we've got y to the first and 2y to the first. Same variable, same exponent. That coefficient, that number in front, is allowed to be different. We're worried about that variable. So we've got 2 like terms. This x is not a like term with anything else. Okay, and the next one, I want to add 4 at the end. So I need everybody to add plus 4 at the end. So I want you to pause the video and see if you can figure out how many terms there are and then how many like terms there are. So terms, I've got 1 term, 2, 3, and 4 terms. However, like term here and here, because they're both being raised to the first power. A is being raised to the first power. 5 and 3 are the coefficients in front. They may be different, but that's okay. We're worried about that variable and the exponent. So again, we have 2 like terms. So you guys try that last one before we go over it. So terms again. Got 1 term, 2, 3, and 4 terms. Like terms though. We've got a like term here because it's x to the second. Here and here. They're all x to the second. We're not worried that the coefficient there is 1, that the coefficient on the other 2 are different. We're worried about that variable and that exponent. So 3 like terms. X is being raised to the first power. So make sure you fill that in, that x is to the first, and that we've got a coefficient of 1 right here. So let's pause the video if we need to pause for a little bit and rewrite this and ask some questions. If not, so we've identified what like terms are and coefficients, and we're going to use those so that we can add and subtract them. So we know how to add numbers. We know how to add 3 plus 2, 5 plus 8, and subtract them. But now there's going to be a variable with them. So to do that, you keep the variable the same, and you're going to add or subtract the coefficients. So remember that coefficient is the number in front. So 5 is the coefficient and 3 is the coefficient. We can only add or subtract them together if they are like terms. So must have like terms. So I would write that down to make a note of it. So we add those coefficients in front. That's how we get 8. 5 plus 3 is 8. And we have that x there still. So if you can also expand it, 5x means x added 5 times. So why don't you go ahead and try these bottom 2 now. So let's pause the video. So if you want to check with me, these are like terms. We can only add them if they're like terms. So we take the coefficient, add them together, and we get 10. And remember, if our variable is raised to the same power, it's a like term, so we need to keep that variable the exact same. So 10x is our answer. So on the bottom one, we can rewrite this in 2 different ways, and it's up to you, whatever makes more sense. Here we've got 3 minus 4 to give us negative 1, and we keep our x there. Or over here we've got 3 plus negative 4, and there should be an x right there. So if everybody could add that x, because without that x it is not a like term. So make sure you add the x there. So we still get negative 1x. Okay, if we would have had what I had before, 3x plus negative 4, we cannot combine those or add or subtract them because they are not like terms. So let's make a note of that. Okay, we can't combine those because they are not like terms.